This is something that came up in one long winter night here at LUT in a discussion over coffee with Dr. Siebert. We are actually thinking whether there is a possibility, just for fun, to use a prototype of a relative type evaluation method and to use it to construct evaluations of absolute type. And as it turns out, it might be possible. So therefore, we are presenting this. So this is a presentation on how we propose to use pairwise comparison methods, so something relative by definition, to get an evaluation of absolute type and to preserve as many advantages of the relative type methods as possible. It gets slightly technical at some point, and actually we have changed the notation during the preparation of the presentation, so I hope that it still can be followed to some extent. So I'm not sure how many of you are well familiar with AHP or pairwise comparison methods, but I guess that we have all encountered those. So I will just briefly remind the perspective of the relative and absolute type evaluation methods just to show what the motivation was. So essentially, if we want to do multiple criteria evaluation or multiple criteria decision making, we have one of those four goals in mind. We either want to select the best alternative, or we want to arrive to an ordering, or we would like to decide on acceptance or non-acceptance of the alternative, or we can actually consider multiple criteria evaluation as a first step in classification if we want to, essentially. And the funny part is that most of these are covered by the most researched methods, which are relative type methods. And not all of these goals can be reached by relative type methods, and not all of them can be reached reliably. So essentially, what is the difference? We know the difference. I just want to make clear why our method is fun to have and why it might have some benefits. So essentially, if you have relative type methods, you need a reference framework. You need something to compare the alternatives or objects to. And the reference framework usually is the other alternatives. So you compare objects with other objects within the set of objects that you are considering somehow. Obviously, if you only have one alternative, the ordering is not a problem, but the evaluation of the alternative, if you only have to compare it with itself, becomes impossible. But then again, you might not have a decision-making problem if you only have one alternative, but you might be interested in the evaluation of the alternative. So this is one drawback of relative type methods. If you only have one alternative at a time, it might be difficult to even use those methods. And a positive thing about relative evaluation is that you do not need absolute scales. So you can have scales which have no minima, no maxima, or at least no natural minima, natural maxima, and you can still get away with it, and you can use the methods. And one very well-known shortcoming is that unless your set of alternatives is finite, unless it doesn't change, then every change in the alternatives, in the set of alternatives, or in the evaluations of the alternatives can change everything. The ordering, the evaluation of the other alternatives, the decisions based on those values, and so on. So essentially, all these methods are very prone to change, and this is not a very good thing. And we usually do not have finite sets of alternatives. We can always expect that we have forgotten something, or that there is something that should have not been included in the first place. So if we want to use these methods, we can have relative scales, but we need to somehow count with the weak sides of those methods. And there are some benefits of these methods. Almost all researchers focus on relative type methods. There are plenty of them. There are many results concerning these methods, many practical applications, and many successful practical applications. So there is a huge body of research to build on. And essentially, since we do not need absolute type values, absolute type scales, it is easy to use those methods. Okay. If we consider absolute type methods. Absolute type methods also require a reference framework. You need to compare the evaluations or the alternatives with something, but the benefit of absolute type methods is that this reference framework should not be dependent on the alternatives, and therefore you should be able to evaluate a single alternative and get a reasonable number that can be interpreted and that can have a full informational value. Also, you need to use absolute scales, and there is this guarantee that if you change the alternatives, their evaluations, if you remove an alternative, if you add an alternative, the evaluations of all the other alternatives will remain unchanged. Okay. There are quite many benefits, but there are not that many absolute type evaluation methods. Surprising. And now, we have methods which are well-researched, easy to use, easy to apply, but which do not allow for something. And then we have the goal of acceptance, non-acceptance decisions, which is a rather relevant goal, and we do not have that many methods to reach that goal. So why not combine those two, if possible? So essentially, as I already told you, if you want to select the best alternative out of the set of alternatives, you can use absolute relative methods. It doesn't matter. If you want to order the alternatives, again, absolute relative methods, it doesn't matter as long as the set of alternatives will never change and as long as the evaluations of the alternatives will never be reconsidered. If you want to decide on the acceptance of the alternative, if you want to do scoring, then the application of relative type evaluation is very problematic. And you should go with absolute type evaluation. Okay, so what would be an absolute type evaluation method in our context? Well, we require these 4 simple features which are usually set, but I have actually never found them on the same page or even in the same paper. So essentially, if you use an absolute rating or absolute evaluation method, obviously you expect the evaluation to be provided on an absolute type scale. So every value can be interpreted. There is a natural minimum and a natural maximum. And these values are also understandable, can be interpreted fully. This is a natural requirement, but not frequently present in the definition of an absolute type method. Also, the ability to decide on acceptance or non-acceptance, so essentially the ability to assess a single alternative is a requirement for absolute type methods. And then these are the usual defining factors. If you add or remove an alternative from the set of alternatives, the evaluations of the other alternatives should not change. And obviously, if you change a value of one alternative with respect to one or more criteria, its evaluation can change, but the evaluations of all the other alternatives need to remain unchanged. And I guess these are not very restrictive. This is a reasonable requirement for an absolute type method. So now, knowing this, with this definition, let's try to apply pairwise comparisons to get an evaluation of absolute type, if possible. Okay. I have already suggested why we should consider relative type methods for this purpose, because we know how they behave. They are easy to use. Actually, pairwise comparisons are very nice methods because you have that repeated measurement inbuilt in those methods. If you consider AHP, you compare each alternative with every other alternative on every row. So essentially, every measurement, every preference intensity is confirmed by another measurement. You have consistency indices, inconsistency indices. It is easy to do because you only ask the people to compare one object with another object. This is what we do in real life. This is actually one of those assumptions of economic theory, that you can compare 2 objects. If you are asked to compare 100 objects, it might be difficult, but comparing one with another, you should be able to do that. So there is a reason to go this way. So essentially, it would seem that data input through AHP or through pairwise comparison matrices might be a good idea. So let's consider it as a good idea, and let's see how far we can get and if we can obtain evaluations of absolute type. First of all, I should say that Sati actually proposed something that could be called, or actually he called it, absolute measurement AHP. I'm not sure if you have ever used the absolute measurement AHP, but at some point Sati was asked, how come that in AHP you do not have that absolute level of measurement? And he said, it has been there all along. It has been there from the beginning. You just do not understand my method. So essentially, he said, look, if you take AHP, but if you do not consider the values of the alternatives, but if you define categories on criteria, so in each criterion you have low, medium, high value of the criteria, you define it on the respective scale, and then you compare these categories, you have supercategories, and you have the evaluations of these supercategories computed by AHP. And then the evaluation goes in a very simple way. You take an alternative, you check into which supercategory it belongs, and then you already have the evaluation because you have evaluated the supercategories. And if you think about this, this already can be, to some extent, an absolute type evaluation method. So this is what I have described, and essentially, you have evaluation on an absolute scale. It has a minimum and a maximum. If you change the set of alternatives, nothing happens, as long as the categories are defined irrespective on the values of categories or of alternatives. And there is no rank reversal. You essentially have the same evaluation for every alternative. You can even evaluate one alternative, a single one. So why shouldn't we use that method? Well, because, first of all, Sati stopped halfway through. He never derived the evaluations on an absolute type scale, even though it is theoretically possible. And second of all, you can still have two different alternatives. They can belong to the same supercategory. So even though you would have preference that one is better than the other, if they belong to the same supercategory, they are assigned the same evaluation, and you are losing information, just for the sake of having an absolute type evaluation defined this way, and for the sake of Sati defending his original method. Okay, this being said, it can be adapted, but the information loss remains there. So let's try to improve the idea of using relative type evaluation for absolute type evaluation. This is the usual setting. We will have M criteria and N alternatives, and now, depending on how familiar or fascinated or pissed by AHP you are, it might be interesting or not. But I will try to go through those steps very quickly and just to show you what we need to do. So first of all, let's assume that we have the weights of criteria. In any way we can calculate them. Direct assignment, AHP, or simple geometric means from a pairwise comparison matrix, something like this. Let's assume that we have the weights. They do not even need to be normalized, but let's assume that the weights are normalized. Then, for each criterion that we have, let us define a positive ideal and a negative ideal. So essentially, let us define the best value and the worst value of the criteria. This means let us introduce an absolute type underlying evaluation scale for the criteria. And either this is possible directly, or we need to introduce artificial minima and maxima in order to reach something like this. But we can easily introduce saturation thresholds, unsaturation thresholds, and things like that. And I will show you a figure or two after that. The main idea is that these values, the positive ideals and negative ideals, so the best and worst values of each criterion, are defined irrespective of the alternatives. They should not be dependent on the alternatives. But if the criteria are meaningful, it is possible for the given context to define these values. And so far, this is sort of Topsys-like. We have positive and negative ideal, but they are not relative. They are absolute ideals. Okay, the next step would be take the evaluation of the alternative with respect to the given criterion and compare it pairwise, but not with the other alternatives, because this would constitute a relative element into the method. Compare it with the positive and negative ideal. We still have repeated measurement. We still are comparing only two objects. It is still meaningful if the ideals are defined in a reasonable way. And at the end of the day, you get an evaluation or a local priority for the alternative with respect to the given criterion for its positive ideal and its negative ideal. And still, we need to understand that since AHP works as it works, the evaluations of the positive ideal and negative ideal, or the local priorities of the positive and negative ideal, are relative so far. They are different for each alternative, even though the comparison of the positive and negative ideal is the same for all the alternatives. But the overall evaluations, the local priorities, can be different alternative from alternative. So far, we have values which are calculated by a relative type method using absolute scales and absolute minima and maxima, and which are still relative. Because this value is different, so the local priority of the positive ideal of criterion E, right, is essentially different for each alternative that we use. So we can aggregate the evaluations, so we can aggregate the local priorities into global priorities. We have already proven in our previous paper that we should use geometric means method to that. And once we do that, we still have absolute priorities for the positive ideals and negative ideals, which are alternative dependent. But we can interpret them in terms of ratios, and these ratios are essentially on an absolute type scale, because we can very easily prove that the scale has a minimum of 1 and a maximum that can be defined this way, or essentially that can be defined, sorry, let me see, that can be defined this way. So both of those ratios are essentially on this scale, and this scale is completely meaningful. There are defining characteristics of the minima and maxima of the scale. And once we do that, then we can use the values, this one and this one, to choose the best alternative, to order the alternatives. We can even use the values to decide on the acceptance or non-acceptance of the alternatives, because we can, on an absolute type scale, we can define acceptance or non-acceptance thresholds, because every value of the scale has full meaning. And now, essentially, this somehow mimics the ideas of TOPSIS, but at the end of the day, it makes AHP an absolute type evaluation method. And what is rather funny about this is that at this point, we can actually, by the introduction, and I know that this is more technical, so you will just have to trust me since I have 1 minute left. At this point, we can accommodate benefit type criteria, cost type criteria, and target value type criteria. All of them can be input into that method and still get an evaluation of absolute type. Again, it gets rather technical, but essentially what we just need to be able to define for each criterion to get that positive ideal, negative ideal, would be to define acceptable values and not acceptable values. So essentially to be able to define this saturation threshold, this number and this number, which means values that define complete satisfaction with that criterion, and we define the values which define complete dissatisfaction of the criterion, complete unsaturation. And by the way, since we are using this in fuzzy set theory for decades, it has proven to be working. So this is possible to do. And at the end of the day, we are working with rather small matrices. We are comparing each alternative with the positive and negative ideal. This value remains the same for all the alternatives because you're comparing positive and negative ideal of the criteria, so it cannot change, alternative from alternative. And if we use this, we get a two-dimensional representation of every alternative as a ratio of its evaluation to the evaluation of the negative ideal, and as a ratio of the positive ideal or positive ideal alternative to the evaluation of the alternative itself. And we can prove that the evaluations will always, the ratios will always lie in this interval. So we have an absolute type underlying scale. And then if we know how to decide on the best alternative using TOPSIS, we can use the exactly same logic to apply it on these evaluations. So we can either select one of the criteria or define acceptability, non-acceptability thresholds that would go, for example, like this. You can say that on this axis, anything closer to the 1 is better than further from the 1. On this axis, anything further from the 1 is better than closer to the 1. So essentially, if you had these two alternatives with this threshold and this threshold, you could say AI is preferred, is accepted, AJ is not accepted. So we have this single shot acceptance, non-acceptance possibility as well. And the computational intensity is very low. We actually do not need to do many calculations, and this is the last thing that I would like to show you. First of all, we have an absolute type evaluation according to our definition, and this can be proven very easily. And second of all, we have built a method that is an absolute type evaluation method using a relative type tool. And if we consider a three-level hierarchy, so we have those criteria, alternatives, and weights, as long as we have 6 or more alternatives, this method requires less pairwise comparisons than the full AHP, which is relative. Okay, this is it. So this is our take on building absolute type evaluation using relative type evaluation tools. If you have any questions, I'm happy to answer those.